All right, you want the good news? You're getting out early. Mainly because, unlike the other talks, this one is, I tried to drill down deep on things for profit for you and to give you the truth behind statistics. The undergraduates are going to get that lecture tomorrow. You can see that this is an older lecture. I need to update the date in the slides. But to give you an understanding of what's going on with a different, let's say, viewpoint of the need for statistics, but also the need for other key things. I will call them the 4 pillars. To give you definitely need to update that slide. I'm no longer chair, thank God. Hard to believe, but 3 years ago, NIH made a major revision to their review process, okay? And that caused a lot of concern, and there was a lot of effort. And I personally believe that this change is a good thing, but we need not to just focus it on NIH. It needs to be focused far more as kind of some fundamental concepts that we should weave in or build in to the foundation of everything that we're trying to do as scientific projects. So I'm going to present it that way, but I am not going to deny that the catalyst was the fact that, oh, we got to address this to have a shot of getting funded. But it's something that's been out there for a long time. What happened and where it came from, if you go back through literature, you will see that there is a lot of discussion, a lot by Francis Collins, appeared in 2014. I'm going to show you some articles also that were follow-ups to that article, which will outline the fact that NIH was going to, because of, and journals were going to do so also, because they felt like results were not being reproducible. Now, I'm going to stop right there and kind of point out something. In 23 years of practicing statistics, there's no such thing as a definition of reproducible that I've come across. I don't know. I did not know immediately what does that mean. Does that mean I reproduce the exact same p-value? Because at that point I started chuckling. I know that that does not happen. There is no way that Margot is going to do the experiment, run the experiment, and then David, me being David, 2 days later follows the exact same procedures, follows it to a T. I'm not going to get the same p-value. P-values measure probability. They measure randomness. Okay? They tell me it's just not mathematically reasonable to expect that. So that cannot be reproducibility, folks. So get that out of your mind. In the cascade that followed this announcement, there has been a lot of articles with regard to, well, it means that we have achieved back-to-back significance, statistical significance. That can't be it either. Not in my book. Because again, if that's the goal, then we need to come up with new design methods. We really need to hit the pause button and think about that. But what NIH proposed is some training models on good experimental design. Okay, I'm all for that. That keeps me employed. That's great. I like good design. They wanted a checklist on the analytic approach. Ironically, this has been going on for 10 years. I've been on study section for over 10 years where I'm brought in to literally review the power calculation and to review the analysis plan and to make certain that it matches, that there's not a bait and switch. So that what the aims state is actually echoed within the statistical components. We spend a lot of time with that. They wanted a scientific premise review. It's key that you understand what that is and what that is not, okay? That caused some other issues. They wanted a big data initiative. I do believe that a lot of what has happened here is due to big data. Something else I can't define. We all use that term, but I don't know what that means, to be honest. Is big data genomic data? Yeah, that's very big data. Is that metabolomics data? Is that the EHR? But those are all very different paradigms that require specialization to talk about if someone's going to try to reproduce. How do we go about it? And there's a lot of published articles on this, okay? This is the RFA announcement saying that there will be new review criteria for all R01s, all Ks, and as in my job in the CCTS, am I being recorded? I'll tell you exactly how I got to be so involved in the rigor and reproducibility. I was leaving to go and drive on Thanksgiving to my in-laws. And somebody said to me, I don't know where to begin. Can you help me out? And I said, sure. And the next thing I know is I'm the king of rigor and reproducibility. And we've been doing that ever since. We actually have a Kaizen course for rigor. And how many of you have done the Kaizen course? How many? And if you want to be certified in this, I'll tell you that at the end. Don't let me dismiss you. I'm still going to get you out of here by 9, but don't let me forget to explain the Kaizen course. So the purpose, you've got to talk about it in the progress report, that there'll be in the peer review expectations. So all these things came up, and here's the biggest thing, the last line. Additional rigor and transparency questions reviewers will be asked to consider when reviewing and scoring your approach. It changed the language of our grants, okay? And it changed a mindset, and it's very sincere. I'm not being critical about it. It is a good thing. So what happened is the following thing. The Scientific Review Committee now asks the following questions. I think these are very reasonable questions to ask yourself as you're conducting any study. Any study. Yeah, let's be transparent because this is rigor and transparency. Do all 4 apply to every grant or every scientific investigation? The answer to that question is a definitive no. No. Okay, I have plenty of studies that not all 4 of these things apply. But you need to be mindful, these are 4 questions you should keep in mind. Key thing, how strong is your scientific premise? Okay, let's be clear, that's not a literature review. Literature review is a sub-component of your scientific premise. Scientific premise is a much broader scope. It is knowing your literature and being able to comment about and state what is the strengths of what is in the published literature. What are the weaknesses? This is not to throw stones at a glass house, folks. This is just to be candid and say, this is was a weakness of the study, or this is a weakness in the literature. and then to talk two more things. In your preliminary results, what are your strengths? What are your weaknesses? And then how does this science, how does this experiment, how does this study address those? That's your scientific premise, okay? For example, later today, I have colleagues coming in from the University of Florida. They're going to be landing here at 11:30. We have been doing studies for years about racial disparities in pain. It is a pretty documented fact that if I put a heat stimulus on the back of a person's arm, I'm not going to burn them. Don't think I'm doing anything like that. In fact, I'm not doing it. It's the psychologist that's doing it. I'm just a statistician. But if I give a strong stimulation, not burning, but it's warm, folks, it's warm. And I ask you to rate that on a scale of 0 to 10 for a constant temperature, African Americans will report twofold the level of stimulation, regardless of age. What's that? Now, that would be a key component of your scientific premise, talking about how solid those results have been demonstrated. Now, if you're going to say, well, we're going to see if the culprit is opioid receptors in the brain, now you've added another component to your scientific premise, because you need to be able to do two things. Talk about how those affect pain and why you think there's a possibility that opioid receptors function differently in two races. You don't lay all that out, you don't have a strong scientific premise. Okay? Now it just needs to be preliminary evidence, but you also have to talk about the strength and the weakness of it. But that's what I mean. That's much more than a literature review. That's really laying down the foundation and talking about all the assumptions that are underpinning your experiment or your study. So that's scientific premise. Robust, unbiased approach. Well, we're going to talk about that. What does that mean? You know, as a statistician, I typically rely on randomization to help me with that. But remember, biases can creep in anytime. And most biases, like it or not, creep in post-randomization. And post-randomization, randomization doesn't help you with anything post-randomization. If it pops up after you randomized, it's a problem. So we'll go through those. And then we talk about biologic variables, such as sex. And boy, when I did the tour, as I call it, through the network, and I went down to Auburn does a lot of animal experiments, and they were irate with the sex as a biologic variable because they were interpreting as they had to double every one of their experiments. They had to test it in males and then test it in females. And I kept arguing, that is not what has been stated. It just means if you're going to study or do an experiment, you've got to be able to justify. If you say, I'm only studying males, you can't do that without a justification. If you're going to say, I'm only going to study females, you can't do that without a justification. And if you don't have a justification, they're asking you to study both. Didn't say power the study to both, but include both in the study. Okay? And this goes well beyond just sex. It goes to age. If you're going to restrict on age, justify. But if you can't give a justification, then open the bounds of age to study that as a biologic variable. And then the one that really caused a lot, because this caused a new form, the authentication of key biologic and chemical resources. That's the one I usually don't have. But guess what? Even if you don't have it, you got to submit the form. That caused a lot of headache, okay? And nobody knew what they should put on the form. I'll help you understand what should be on the form, okay? So I've just kind of walked all the way through that. The revised grant applications, we talked about all those. The reviewers are told, and I have been briefed at the beginning of study section, that you have to comment on these things, and we do. We go through each one of these, and it's just wise to address them. Again, I think I would argue my expertise, most of all, falls in the rigorous experimental design. We're going to talk a lot about that. We're going to talk about biologic variable. How would we control for that, or how would we address that in a study? I will go through all of these. Some revisions have happened. I just kind of went through the scientific premise, and I think the key thing, you have to talk about the rigor of the previous studies. All right, now here's the problem. I publish. I know that when I write a grant, I write typically 3 full paragraphs for people that detail step by step. This is what we're going to do. And what do I get when I get to go publish?
3 sentences.
I get 3 sentences. I go from 3 paragraphs to 3 sentences. So it can be kind of hard to be able to address these things. But when you reach out, again, and this is what we have to do. Sometimes you have to reach out to the investigators to talk about, can you tell me the nature of the experiment? We're doing this very much with Florida. We're having almost daily communications with a group in Massachusetts because we're doing very similar to what they've done, and we want to know, are our procedures comparable? And in a lot of ways, like I said, I'm being recorded. We're holding each other accountable for how rigorously 2 things. Are we documenting what we're doing? Okay, documenting it, because that's part of reproducibility, is that you have a document that says, this is the compound we used. This was the manufacturer that we bought it from. This is the schedule, how we knew it was still active. We didn't just go 2 years assuming the potency was consistent over 2 years. We did the following things. So how rigorous was it? And did they account for sex differences? All of those things. So this is the one that was, and I just kind of told you exactly the underlying key thing about biologic and chemical resources. How many of you, if you were going to put it, and this would be one of the things you would have, if you could squeeze the sentence into the manuscript, it would be very beneficial going forward. How many of you are using chemical reagents? Cell lines. Anybody using cell lines? How do you know the cell lines aren't contaminated? How do you know?
Usually sequence them.
Thank you. Will you put that sentence into your next manuscript for me? And will you tell me a little bit, just one detail, how you sequence it? When did you sequence it? And did you do it more than once? There you go. That's all they're asking for, folks. A schedule, a strategy. Because one of the things, if you do the Rigor and Reproducibility Kaizen course, there's some articles out there that are kind of scary about, we're doing a lot of experiments on cancer cell lines. They're not cancerous. They may not be cancerous. These immortalized lines that we're reproducing and cloning, there's some question of, are we sure those are cancerous? And we're going back and we can't find what? The documentation. So if you're doing that, that's not good. So the whole thing about biologic and chemical resources, so the biologic is cell lines. Okay, that's what I'm getting to. Cell lines is one thing to consider. Chemical resources, are you using reagents? All right, so I came in growling, and yes, my stomach is also growling. That's probably why I'm kind of cranky this morning. But I came in, the first comment I made to you was, I love teenagers, because me and my teenager, my 14-year-old, just scraped this morning. There's no other term for it. We scraped up against each other. But to get you to understand something, tonight, when I get home, to apologize because I growled too much this morning at her. We will bake. Yes, I end up baking with my children. It's one of the things that I like to cook. They like to cook. It's a nice way to kind of repair the bridge when I accidentally damaged the bridge or drove into the bridge. But one of the first things I taught her was this. Sweetheart, if we're baking a cake, take the baking powder and take a pinch and drop it into water. Why?
Make sure it bubbles.
Make sure it bubbles. I got to cook in the room. Why?
You know it's still active.
I know it's still active. That is all they're asking for, folks. That's what they're asking for. Can you get some form of measure? Because if it bubbles, we can get CO2 out of it. We can make the cake rise. But guess what? That baking powder that's 2 years old, you drop it into the water, it just sits there. It's useless to you. It's not going to help you do what you want it to get done. That's all they're asking for. And keep in mind, they only gave you one page to write this up. That's a benefit to you. They're not asking. Now, the classic question that came in is, well, what if I'm buying my mice from Jackson Lab? Can I just use their documentation? Technically, yeah. You can say, yes, and ask them for that information. Or if you're buying chemicals there's already stuff on the web that allows you to say, well, it has been validated or verified according to these, that's fine. But the key thing is, if you really want to be very good, the biggest thing that I said to you was, give me a schedule. A one and done approach is not really good. Don't say, on day one, when you give me notice grant award, I'm going to do all these experiments and then just go forward. And some people wrote their chemical and biologic resources that way. And that did not fly. Okay? And again, it's good science. If it's a 5-year project, folks, you gotta schedule this, okay? And that's all they're talking about. And let me go back. If you have none, this does not apply to you, I am doing a behavioral intervention, and I have no chemical. I'm not giving them any chemical, and there's no chemical or biologic reagents. You still gotta load up the form. Don't be shocked if you're dealing with NIH. You know what you put on the form? Don't leave it blank. It'll get rejected. What do you put on there? This study does not incorporate any chemical or biologic resources that need to be authenticated. Period. Please do that. But this is what I call my baking powder requirement. Now, 10 to 1, you'll never forget that one. Okay? This is the one I can still remember. I went down to Auburn to give this talk. I was invited, and it was fine. And once I got to this one, the whole thing just came to a screeching halt.
And what?
Came to a screeching halt because they were worried. Understand what I just said a minute ago. Sex as a biologic variable is not the only one. Please be mindful of race. Please be mindful of age. Okay? All these things. that you might want just to put in your statistical model. Ask your statistician, when we're going to be looking at the data, can we analyze it with sex as a covariate to see if there is any indication that the outcome may differ by sex. That could lead to future research. This is not, may I say it again, this is not a requirement to power every study to find a difference between male and female. This is not a requirement to power every study to spot a difference between the elderly and the young. This is a statement to say, if you are studying prostate cancer, it is okay to say, I'm only studying men. If you're studying breast cancer, it is not okay unless you've got a justification, because some men do get breast cancer. However, if you have a reason to say, no, we want to focus on women for the following reason, got to provide the reason. You just cannot unilaterally say, I am choosing to study one subgroup without justification. And if you are studying and have both sexes, then they're not asking you to look, they're not even telling you to build a hypothesis test on that. They're not saying anything about your specific aims. They're just saying, if it's there, first ask the question, is it possible that there's sex differences? Doesn't have any power, but be mindful that there are potential differences and discuss it. That's all. This is the one that I think actually I've had the best success of addressing. Yes, ma'am.
That brings an issue up for me because I want to know, the form where you have to put in the numbers.
Mm-hmm.
Well, I look only at older African American
Mm-hmm.
veterans, right?
Mm-hmm.
And I give justification for why I study them, but I always have to go to the records to see if anything changed with female veterans who are Black who live in Alabama.
Mm-hmm.
So then I come up with some crazy number, percentage that is likely to be in the study. So the last study, I think I said 3, I got 1. So then what happens?
Well, under that case, you have to be very honest to be able to say that given my demographics, because that's the other thing, I've done plenty of VA studies. You asked me to go in and I've done large VA studies. If you ask me to go in and look for a sex difference, that's a problem. 97% of my participants tend to be male. 3% female. And you can say, well, go on and test it. I can't. Not in a regression model. There's a reason not to do it. The justification is I can't do that because of collinearity. There's a statistical limitation at this point. And I put that down and use it.
Thank you.
Okay? There's no way I'm going to advise you to try to do a hypothesis test of 149 versus 1. No, I'm not doing that. So there, we just have to acknowledge the limitations. And I think that is acceptable to both journals. I don't want you, here's the problem. When I did this talk back in December of 2014, it was an NIH focus. I don't want you to have an NIH focus. I want you to have a publication focus. I want these details in your papers. I want these details in your studies. Okay? That way we're actually having the impact. Because one of the hardest, and I'll tell you, what's the hardest thing about reproducibility? It's lack of documentation. It's lack of finding the details. Okay, because when I say reproduce, okay, I literally mean Can you produce, going back to my cooking examples, can you give me the recipe for your experiment? Can you write a recipe for me? That way I know the steps that you went through to do this. And when I go to recreate your experiment, I can follow your recipe. Do I expect to get the exact same cake? Of course not. Humidity affects those things, right? I'm cooking in a different oven. That's going to change some things, right? Altitude will affect it. So to, quote, reproduce perfectly is impossible. But at least I can reproduce the scientific aspects of your study, and then I see how close my results are to your results. That's what we're getting to with reproducibility, folks. Okay, now this is the longer part, because this is where I was more comfortable. This is more in my wheelhouse. So rigorous experimental design. Oh, well, guess what? They would expect a sample size estimation, one that somebody else could reproduce. We were on top of that. I actually felt like at UAB we were very good about doing that already. Blinding, we do that. Replicates, all the statistical methods planned and written down before we begin the experiment. We were good about that. We're always very good about writing out inclusion, exclusion criteria. What we're not very good about is actually archiving all of it. I'm sorry, I'm serious. We're not very good about having a place where all this information is stored, so when somebody comes back in a few years and says, how was it? Or what did you do? That's what we typically have struggled with. This is to help you understand if you're submitting a grant, if you're going after, guess what? This isn't a K. This isn't an R. This isn't an F. This is across the board. This table just helps you understand. Does it apply to all applications? Yep. Okay. Notice I said down here is only for projects involving for authentication of key biological and or chemical resources. It's only that one, but you still got to upload the form. Where should you find it? Where should you put it in your application? Because you know what? I've been on study sections. We expect certain things and expect in certain areas, and if you don't put them there and you put them elsewhere, we punish you. So, premise should be in research strategy, rigor, research strategy, and specifically significance, rigor, and the biologic variables, both in approach. Where do you find it in your, when you get your critique back, it breaks down. It'll be in significance, approach. And these are the questions that we literally have to answer. Okay? I would argue that these are very good things for you to consider a priority before you begin any experiment. Is there a strong scientific premise for the project? How strong is that? It's going to help you with your background and your significance in your grant. It will also help you with regard to the introductory paragraphs of your paper. Is there a robust, unbiased approach? We'll get a little bit more into that in just a minute. Yes. Are there plans to address the biologic variables? Or justification when you don't? And then comment on plans for identifying and ensuring validity of resources. If I had to redo this slide across the lifetime of your experiment, across the lifetime of your study. All right, this was my major contribution to that one week when before I started driving my kids to Virginia with my wife. I found an article in Science that was addressing rigor and reproducibility, and we really came after I shouldn't say it came after statisticians, but it came after all of us, and it really hit me. I do this. I actually do this. I make these mistakes, and I'll be very honest about it. There are cognitive fallacies in research, and in fact, I'll probably throw myself under the bus with some stuff I did last week, come to think of it. you know, and then it was really a review article, but the things that we often do we ever really, do we get so convinced that we're right, that we're mainly emphasizing the evidence that supports our research hypothesis and downplaying the evidence that maybe our research hypothesis isn't true? Yeah. Oh, I have to do this all the time. Texas sharpshooter, seizing on random patterns in the data and then trying to explain them. Yeah. And mistaking them for interesting findings. Oh, that's really interesting. Let's just change our hypothesis to that. No, that's a no-no. Can't do that. Though you're laughing, we all struggle with that. Keeping the main thing is rather kind of hard. The asymmetric attention is what I am so guilty of. And I'll tell you exactly what goes down when, after I've gotten all the data and I'm starting to analyze it, and I go over and I sit down with the investigators, or we sit back here in the kitchen and we're looking at it. If the p-value is below 0.05, we are all for it. Let's go. And do we go in and look for an outlier? Do we go in and look for influential points? Do we go look at all the normal probability plots? Nope, we're happy. We got the p-value. Let's go. But if that p-value is above 0.05, I wonder if there's an outlier somewhere. Did that contaminate it? I wonder if there's an influential point. Did that change the story? Hey, maybe I should use another test. What's wrong with that? You've got to use the same standards regardless. You should, if the p-value is less than 0.05 and you're still worried about the statistical assumptions, then go on and apply the robust test. But don't alter your strategy based on the result of your data. There's a great book. And when I say a great book, I'm not saying go buy it. I just found it amusing in graduate school. There is a book, classic book, that almost all statisticians get trained in multivariate data. That's where we do like factor analysis and principal components. But it's by Johnson and Wishart, and there's a comment about factor analysis, and they said the acid test for factor analysis is this. When you hand it to a psychologist, they go, wow, this makes sense, it was a good analysis. That's literally in a stats book. That's the wrong approach, folks. You don't find stories and then rationalize them and turn them into hypotheses. Because guess what? If you sell it that way, the chances of people reproducing it or being able to get the same results, no. Because what really is happening is you're taking a random event, making a story around it. I'm not going to get the same event. Debiasing techniques. Being the devil's advocate, when you get the data, is the data really telling a different story than you expected? And being honest about it. Pre-commitment, I did not choose that engagement ring. Somebody else put that on my slide. Publicly declare a data collection and analysis strategy before and put it out there. This is one of the things do y'all know about ct.gov? clinicaltrials.gov, as a requirement by NIH, if you're doing a clinical trial, that you need to register it, and in that registering of it, that you need to go ahead and you register it at the beginning of the study, not at the end. And at that beginning of the study, you register it and you say what your outcomes are and how you're going to analyze it. And it's stated years before the experiment's done. Team of rivals. This actually I find is the hardest thing to do. Invite your academic adversaries. I don't like the word adversaries. I prefer the word enemies. To collaborate with you on a study. I do think is wise, honestly. if you have strong relationships, and I jokingly said enemy adversaries, if you've got colleagues that work outside, that understand your research, for them to be able to be given a blinded copy of the results. Don't reveal to them what Group A and Group B is, but just let them read the results before conclusions are stated, blinded, and ask them, do you see anything in this that you need more information about? Do you need more information about the statistical analysis? Do you need more information about how the experiments were conducted? And then allow them to get all those, and after it's all said and done, then if they say, well, which group is which, show them at that point. That way they're not biased. They're not biased by an expectation. The blinded data analysis, I actually kind of like, we do this a lot among statisticians. We don't blind ourselves. But if we give Andy Westfall the data set, we give David Redden the data set, we are told, you need to do the following analyses. Specifically, this is the hypothesis. They're asking for a regression analysis. We both do it. We both do it. And then we compare how comparable are our results. Okay? We didn't blind each other, but we actually did dual analyses. Did we both identify the same outliers? Did we both have the same concerns about any of the assumptions? Or were we all both, this is all clear, assumptions are met, yes, there are a few extreme points, but they should be there. Folks, if you have outliers in your data, that doesn't mean anything's wrong with your data. They're going to happen. I'm more worried when you bring me a data set and I don't spot an outlier. I come back to you and go, did you remove somebody? Because there should be outliers present. So, idea, all assumptions required, and this, you've heard this a few weeks ago, always put all the assumptions into a power calculation. Justify the sample size. Say what it is up front. Always include a data management plan. You know, I'll be very honest, one of the things that people have a hard, again, I'm being recorded, I can tell you, I was in a meeting yesterday that discussed, can you help us? And I said, what's the issue? We're trying to reproduce a set of statistical results. I said, future or retro? Did you hear what I said? Are you doing a new experiment or are you doing retro? They said retro. Why should that be a problem, right? Here's the reason. Nobody saved the code. Nobody saved the statistical code. It was using a graphical user interface, so people pointed and clicked through a machine, so they don't know exactly all they have is the results. And even worse, they don't know what data set that was operating on. There are 4 versions of the data set. Which one was it? These are issues. This is the only way to address this is through data management. And that's to have a good strategy. Always is archived. All right. Again, you have to have archives. You've got to be able. Now, if you've got a lifetime study, so are you all ready for this? When we do the clinical trials and data coordinating centers over in biostats, we back up nightly. We back up nightly. I can roll back. You mean to roll back to December the 25th? Okay. Okay. Because to be able to know and see the evolution of the project. Now, do you need to do that consistently? At a certain point, all those archives are going to have to be moved somewhere and stored. Somebody's going to have custody of them. If you've got a small study, do double data entry. Okay? You know, and you say, David, that's extra work. Nevertheless, one outlier in small studies can really hurt you. One typo in small studies is very dangerous. If you give me 500 and you make a mistake, less damage. Is it a quick way to do it? Always ask whoever is working with you, have they come in to identify unusual, atypical observations? Because guess what? Sometimes the reason the data can't be reproduced is because people are having trouble in future experiments, is the whole result depended on 2 observations in the original data set. They were influential. Ask the people you are working with, have you done logic range checks? Have you tried to identify leverage? Have you tried to identify outliers? Because if I find an outlier, an extreme one, I'll come back to you and say, just confirm this for me. I did this with somebody the other day. We were studying STD rates. And I'm like, that's unnaturally low compared to everybody else. Can you confirm that that's what was actually reported by the CDC? Waited 2 weeks and we got an answer of, yep, that's the value we believe it is. All right, I have no choice but to use it, but we confirmed it. All right, please try to avoid using what are called GUIs, a graphical user interface. Okay, again, I am not the type that says to you, you can't do your power calculations. You can, okay? It would be wise to have a methodologist look at it. If you're doing a 2-sample t-test, I think most people, Excel has a reasonably good program for a 2-sample t-test inside of Excel, okay? That's fine, but have someone look at it and then make certain that it's been validated in the exact code and the exact data set that produced that result are stored. And I store them in triplicate. Investigator has it, I have it, and I have a backup. That way, and the other thing to do is to be able to, it's just a careful thing to say. Make certain that down the road, if somebody contacts you, you can pull it. Third backup is in a safe at the house, usually, on an encrypted thumb drive. All right? All right, always remember, when a paper is submitted, now you see how I've kind of transitioned from what NIH is to what we're doing in projects. Final raw data set, documented program that prepared the analysis-ready data set, a documented program that conducted the analysis. And notice what I just revealed. Nobody analyzes raw data. Raw data is too messy. There has to be some manipulation, and I'm sorry to use that word, some either calculation, some cleaning, some quality control is what we call it. And then the output, all of it has to be archived together. Because I tell you, I know that there are some big studies out there that if you came to me today and said, can you or a member of your department put your hand on the analysis data set for that publication, I'd break into a sweat. Okay? Always, Pat, if you've conducted your own analysis, ask somebody else to verify it. Let me put it this way, if 2 independent researchers come to the same results, you get greater confidence in the conclusions. So, like I said, it's very common for UAB methodologists to reach across or to have multiple people review the analyses and say, did I miss something? Would you have done it this way? The whole idea of being able to reproduce, to me, is that concept of a recipe. Can you write down everything it would be necessary for somebody to try to conduct your experiment again? That's reproducible. And I will end up saying sometime very clearly, I do very much believe in the Indian proverb, you cannot step in the same river twice. Rivers flow. That's not the same river. You can't step in the same river twice. That's not what reproducibility means. what reproducibility means is you can give somebody either the complete recipe of the experiment, or you can hand them everything that was necessary to see those results. That's what I mean by reproducibility. The other thing, and this is getting kind of deep, I need to come back and check on the stat rep package, but one of the cool things that has been going on the statistical side of everything, the methodology side, is for us to be able to produce documents that literally, as a rough draft of the paper, just a rough draft, not what's published, but as a rough draft of the paper, there are the paragraphs of the paper, but if there's a figure that's going to go insert figure here, we have code now that literally can embed in the draft where the data is that produced the graph, where is the code that produced the graph, and if you wanted the code to be dropped right there in the draft so people could see it in the future. That's what Knitters does, that's what and StatRep ends up doing also. Other places where you can find some useful stuff, the Bird is always a useful, shameless promotion. Can always help. Also, panels are very good about this when you're about to submit something or submit a paper. They can help you through all this, and there are plenty of resources for Rigor, reproducibility, and plenty of videos on the webpage. And with that, it's 9 o'clock. I got a question for you. So the Kaizen game, really quick. All K's, F's, everybody, and again, people get frustrated when I say that. That's where the requirement is. I would think it's not a bad thing for anybody to go through. It's a game, folks. That's all it is. We run it pretty much every 6 weeks. It's a game, but it's a fun little game where, if you register for it, we break you into teams just to have fun as competition. And I designed the game to go through 4 weeks. On Sunday night, I drop you a review article. It's nothing deep. It's a review article. It talks about the issues with cell lines. It talks to you, it goes through the article that I drew those fallacies from. You get 3 days to study it. Just study it, mark it up. And then on Wednesday, we drop 5 time questions to you, kind of playing like Jeopardy. So when you're ready, you just log into the game, you hit the question, and it drops. Now, we've added where there are videos that kind of coach you a little bit, but after 4 weeks, you've gone through the whole thing, and we give you a certificate, and furthermore, through LMS, you get documented as having completed the course, and you can list that on your grant application. Yes, ma'am?
A great selling point for you Trekkies out there. Star Wars.
Oh yeah, we do Star Wars. Yeah, that was not me. That was Brian Wallace. You break into the teams that we assign you to all have Star Wars connections.
And the points.
In the point system and the badges, you get lightsabers. If you go on a running streak or a great streak, you get to have a new color lightsaber and all that. That was Brian. I tried to talk him out of it. I tend to be a little bit more serious than that, but I did come up with the team named Dead Jedis.
Oh.
So a bunch of dead Jedis. So.
Do we know when the next game will start?
I can start. That's the other thing that's so luxurious about that is I can start that game any day. So I'll check with Brian and get that information back to all of you. Okay, but we can run multiple games simultaneously. But no, I don't know when the next game is. But I will get that emailed out to all of you if you would like to do it. Okay? Okay. There's a lot of food out there. This is not, let me tell you again, this is not a 5-minute biologic break. This is goodbye.
Oh, yes. Well, very good. Gotcha. So I'm not a cellular person. So, folks, I need to
A couple weeks ago, we talked about looking at a project and working on stuff like today.
Yes, sir. I'll make some food.
Thank you. Yeah. Huh? You finished early?
Take care. See you, Miss Jean.
I have to say.
Thank you.
You're welcome. I'll be right back. Get said we've been talking about it, I'll be back in just a couple of minutes. More food.
I've gotten 3 emails this morning alone from Rebecca Edwards, Dr. Nice, and Dr. Tristan about that bullying and bullying from ANA. Anyways, I got 5 of them over the past month. Like, I've signed up for this thing like
Yeah. So they're just telling you that it's happening.
I guess they may put it back on our website. I don't know. It's really,
Was it you? Was it your, is it you speaking?
no, it's someone else ready to look it up, but it's truly like my topic.
Yeah.
Yeah, so I need to like, connect, I need to like, reach this person and connect with them. But it's cool because even the director of research or the dean of research is yeah. She's a little.
I don't have a course, but it's.
No.
Or